This presentation, quantum number, is mainly for first semester students of our college, College, Adarampattinam. This topic, quantum numbers, that is very simple topic. This topic is present in the syllabus of UG and PG also. And this topic is a very important topic. The questions are frequently asked in this topic, quantum numbers. This slide shows a request to viewers. Quantum numbers. Bose-Atom model could not explain the fine structure of hydrogen, that is, principal quantum number n alone is not possible to define the energy of an electron completely. It is now known that 4 quantum numbers is necessary to define an electron of an atom completely. What are the 4 quantum numbers? One is principal quantum number, and second one is azimuthal or orbital quantum number, and third one is magnetic or orientation quantum number, and fourth one is spin quantum number. Now first one, principal quantum number. The number of orbits in which the electron moves is given by principal quantum number, and the symbol of the principal quantum number is n. It takes integral value from 1 to infinity, but principal quantum number 1 to 7 have been established so far. According to both assumptions, the angular momentum of an electron is given in a given orbit is nh by 2 pi, that is nh cross, where h cross is a reduced Planck's constant and n is the principal quantum number. And if n is equal to 1, then the shell is k shell, and if n is equal to 2, then the shell is L shell, and if n is equal to 3, then the shell is M, and so on. And the maximum number of electrons in each cell is given by the formula 2n square, where n is the principal quantum number. Second quantum number is azimuthal or orbital quantum number, and the symbol for this quantum number, that is L. In order to explain the fine spectrum of hydrogen, Sommerfeld scientists found that the movement of electron is in an elliptical orbit. That is, for a given quantum number, more than one elliptical paths are possible. In order to represent the energy of an electron in an elliptical path, one more quantum number is necessary, and that is given by this azimuthal quantum number. And the symbol for this quantum number is L, and the L takes the value of 0, 1, 2, 3, etc. up to n minus 1, where n is the principal quantum number. For a given value of n, principal quantum number, there are n number of L values. That is, if the principal quantum number n is equal to 1, then there is a one value for azimuthal quantum number. And if the principal quantum number is 2, then the possible azimuthal quantum numbers are 0 and 1, 2 numbers. And if the principal quantum number is 3, then there are 3 azimuthal quantum numbers, 0, 1, 2, 3 quantum numbers, azimuthal quantum numbers. When n is equal to 1, principal quantum number is equal to 1, then azimuthal quantum number L value is 0. That first orbit has no subdivision. That orbital is s orbital. When n is equal to 2, then the L values are 0 and 1, and that is second orbital has two subdivision. The two orbitals are represented as 2 0, that is 2s orbital, 2 1, that is 2p orbital. Here 2 is the principal quantum number, and 0, that is azimuthal quantum number in the first case, the case of 2s orbital, and in the case of 2p orbital, 2 is the principal quantum number and 1 is the azimuthal quantum number. When n is equal to 3, the possible values of L are 0, 1, 2. That is, third orbit has 3 subdivision. The 3 are represented as 3 0 or 3s, 3s orbital, and 3 1, that is 3p orbital, 3 2, that is 3d orbital. Here 3 is the principal quantum number, 0, 1, 2 are azimuthal quantum number. If the azimuthal quantum number is 0, then the orbital is s. If the azimuthal quantum number is 1, then the orbital is p. If the azimuthal quantum number is equal to 2, then the orbital is d. If the azimuthal quantum number is 3, then the orbital is f orbital. When n is equal to 4, principal quantum number is equal to 4, then possible values of azimuthal quantum numbers are 0, 1, 2, 3. And here azimuthal quantum number 3 corresponds to f orbital. And here the symbol S, P, D, F. These terms correspond to sharp, principal, diffused, and fundamental. That is the first letter of these words. Sharp, that is s orbital, principal p orbital, diffused d orbital, and fundamental f orbital. These are about azimuthal quantum numbers. Third quantum number, that is magnetic or orientation quantum number. The above two quantum numbers, that is principal and azimuthal quantum number, could not explain Zeeman effect and Stark effect. That is, Zeeman effect means that is splitting of spectral lines by magnetic field, and Stark effect means splitting of spectral lines by electric field. In order to explain these effects, another quantum number, namely magnetic quantum number, the symbol is M, was proposed. And the magnetic quantum number, the symbol is M, and the values takes values M, magnetic quantum number takes values from plus L to minus L, including 0, where L is the azimuthal quantum number. When L is equal to 0, M is equal to 0. That is plus 0 to minus 0, that is 0. That is, the electron in s orbital has no preferential orientation. That is, degeneracy of s orbital is 1. When L is equal to 1, and the possible values of M are plus 1, 0, minus 1. That is, the electron in p orbital has three possible orientations, which are called as px orbital, py orbital, and pz orbitals. That is, the degeneracy of p orbital is 3. When L is equal to 2, azimuthal quantum number L is equal to 2, then the possible magnetic quantum numbers are plus 2, plus 1, 0, minus 1, and minus 2. That is, the electron in d orbital has 5 possible orientations, which are called as dxy orbital, dyz orbital, dzx orbital, and dz square orbital, and last one is dx square minus y square orbitals. That is, the degeneracy of d orbital is 5. Similarly, f orbital has 7 orientations with the magnetic quantum number values plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. These are about magnetic or orientation quantum number. The fourth quantum number, that is spin quantum number. When the emission spectrum of hydrogen, lithium, sodium were examined by high resolving power spectroscope, it was found that each line in a spectral series is found to be made up of two lines. That is, each one is found to be doubled. To explain doublet nature of nature, it was proposed that when an electron is moving around the nucleus, it also revolve around their own axis, and this is called electron spin. The electron spin also contribute towards the total angular momentum of the electron, and the spin contribution towards the total angular momentum of the electron, that is given by the formula root s into s plus 1 into h by 2 pi. Here capital S, that is total spin quantum number of the electrons. There are two possible values of spin quantum numbers. What are the values? One is plus half, another one is minus half. If the electron in spin in a clockwise direction, then the spin quantum number is plus half. If it is in anti-clockwise direction, then the spin quantum number is minus half. And here the plus sign and the minus sign, that is clockwise and anti-clockwise direction of spin. If the two electrons in an orbital are having the same spin, same direction, the electrons are said to be unpaired. And if they have opposite sign, they are said to be paired electrons. That is, if electrons are in plus half and minus half values, then we say the two electrons are paired. If the two electrons are having plus half and plus half, then we say the electrons are unpaired. With this, I want to conclude the presentation on the topic quantum numbers. So quantum numbers, these are used to denote an electron in an atom. There are 4 quantum numbers. that is principal quantum number. Second one is azimuthal quantum number. Third one is magnetic quantum number. And last one is spin quantum number. These quantum numbers are used to denote an electron in an atom. These are about quantum numbers. Questions are frequently asked in this topic. What is meant by quantum number? What are various types of quantum number? Explain quantum numbers. These are the common questions frequently asked in the university examination. Thanks for watching.